All right, welcome to H-paired Algebra 2 for Tuesday, May 19th, 2020. All right, welcome. One more next to the last class for the school year. Mr. Daniels, Carpin, Baird, Action Jackson. Just a reminder, you're supposed to have your video on. Make sure you're actually that person. All right.
I can.
Here comes the late
My audio works on my computer, and then on my phone the camera works, but the audio doesn't. Because I dropped my phone in water. No.
Easel.
Mr. Kirsten, why are you always late?
Oh,
well, kind of like whether it's a video class or after.
Cheese man.
We're always late.
Nick, where are you driving? Why?
Sir,
Nick,
how
don't
was your
crash the
cookout this
car
weekend?
like last time.
Okay. Here, let me go over some announcements.
Okay.
All right. Admin folks have said that Thursday's the last day of class, and it's the last day we can accept any work. All right. So if you are missing work, you've got 4 to 8 hours to get it to me. No ifs, ands, or buts. Now, just as a refresher and reminder, and I've said this many times, you may be missing stuff that you believed you'd submitted, and maybe you did. But if you remember back about the second or third week we were into this, Blackbaud went down for like 6 days, between 5 and 7 days. And things got lost in the shuffle there. And then some folks submitted things with no names. I've got a stack of probably 3 dozen different quizzes and problem sets with no names. And so unless you've got a very distinctive Mr. Baird or Mr. Carpin handwriting, I can't recognize your handwriting, so I can't just arbitrarily assign it to you. So you got between now and Thursday, no ifs, ands, or buts. So don't even ask if you've got stuff missing. You can get it in. I'll give you partial credit. All right. Thursday's it. Any comments or any questions reference that? Pretty good. All right. All right. So here's the plan for today. Let me just check something here. 6-5 quiz. Let's see.
Sorry, you said the school year's
Mr. Porterfield, you're working on that 6-5 quiz. For some reason, I didn't get one from you. I don't know where it got lost in the shuffle. I was corresponding with, probably conveyed that emails we had going yesterday. All right, everybody else is good to go. All right, any questions before we get started? Okay, here's the plan. I'm going to share my screen with you. I'm going to, since it's real hard to write real legibly, I'm going to just post my answer key for 6-6 problem set 2 and talk about it in a refresher. Okay, and that's going to kind of wrap up 6-6 problem set number 2. I'm going to go back through and just kind of go over some of the key points from 6-4 and 6-5. 6-4, and you've got you've already taken quizzes on those. I'm going to pull them back up and do a kind of quick review or refresher. 6-4, 6-5, and 6-6 are all kind of close cousins to each other. They all revolve around radicals and exponents and kind of going back and forth, converting one to the other and the other to the original. And do a quick little refresher. And what I'm going to do is pull about 10 questions from each of those 3 sections and make a test. That sounds like a test in the quarter, but I inadvertently, we didn't have a test early in the quarter, and they want us to have at least 1, if not 2. But it's going to look more like a quiz on steroids. So it's going to come from your 6-4 quiz, your 6-5 quiz. And I know it's challenging since you don't get the quizzes back and you can't exactly see, how well or, what you did well on and what you may have struggled with. But I'm going to do a brief review on 6-4 and 6-5 and I need you to take it before Thursday at 10 a.m. Okay, but it's one sheet front and back, about 10 questions from each of those 3 sections. And it shouldn't take you 30 minutes because some of them are quick answers, and you'll see why I'm saying that here momentarily.
So another quiz.
Yes, sir. One parting shot.
Ugh,
Oh no.
ugh. How about you take
Burrito.
the question?
Burrito, sir.
Wait, so sir, I thought there was a test on Blackboard. That's not like we're not doing
Random
that.
no shirt
Oh,
on.
Dude,
Josh.
Jaden, please shave. That's not
Beard,
tough.
shirt, Room Doom.
Jaden, you have the meanest chin strap I've
Burrito.
ever seen.
Guys, I was talking to Mr. Gaffney.
I don't care.
Mr. Doctor, make sure you got a
One
shirt on.
goal.
All right.
Taco.
I've already loaded it. Listen closely. I've already loaded it on Blackboard. Okay. It's there ready to go. And it's labeled as a TST, as a test. So it counts more than a quiz, so make sure you take it. Now, if you pay attention these next 30 minutes, I will have you fully prepared so that you should get at least a 94 on this. So, are we ready to go? Before we have any questions before we fire this thing up? All right, so you should have 6 problem set 2 in front of you. Let's check your work versus what answer key, okay? All right, so here we've got identical bases and we're multiplying. And remember, we add the exponents when we're multiplying identical bases, right? So exponents, remember the root is on the bottom, the exponent is on the top, all right? So in the fractional format, when we add and subtract fractions, you have to have the common denominator. So all we did is add the 4 and 6, which is x to the 10th root of 5, all right? 10 over 5, last time I checked, was 2, okay? So x squared should be your answer. Number 2, here your exponents have exponents. We've got one base, so we're actually multiplying. 2 times 3 is 6, 3 times 4 is 12. The 6 over 12, 6 power 12th root can be simplified to y to the 1/2, right? Which actually is the same as the square root of y. Good so far? Everybody good? All right. Just clear up my drawings. All right. Here we got identical bases. So we're going to add the exponents, but we don't have common denominators, so we converted the 4/5 to 8/10. That way we can add the 8/7, which is 15 over 10, which can be simplified to p to the 3rd power and the square root of that, all right? So, I mean, if I put it in radical form, it would look like this. P cubed, and I could put that in parentheses, but I won't, and it's the square root of that, right? Number 2 is like number 4, where we just multiplied 6 times 2 is 12, and 5 times 5 is 25. Easy money. Everybody got those? Easy money. All right. Go to the back side. All right. Again, we're just adding the exponents. We have to get a common denominator. All right. All right. So the common denominator was 24. So 3/8 is 8/24, and 4/3 is 32/24. So the final answer is x to the 41st power over 24th root. Stop me if you have questions or you're not getting these answers. 1 times 4 is 4. 3 times 6 is 18. So that's the product of that, and the 4/18 can be simplified to 2/9. All right, so here we're dividing like bases. So instead of adding like we did up here when we multiply, we are actually subtracting. So p to the 1st is the same as p p to the 3 over 3, right? So I've got a common denominator. So 3 minus 1 is 2. So there's your final answer of p to the 2/3 power. Everybody get that one? All right. Likewise, again, we're going to have to get a common denominator because we're going to subtract the denominator from the numerator. We got 3/6 minus 2/6 for 1/6. Or it's the 6th root of x. These are the same, two different ways of expressing the same thing, right? All right. Hope we don't have Mr. Neighbors have an accident. Here we go. Let's see here. All right, let's see here. I think we're on number 9. All right. So we're taking the 6th root of 128. So hopefully what you did here is you just started dividing 2 into 128, which was 64, and then you kept going all the way down the line. And then actually you found out it was 2 to the 7th power, right? So 2 to the 6th power comes out as 2, right? 2 to the 6th power comes out of the 6th root as 2, leaving a 2 under the radical. All right. 49, bells and buzzers went off, you know is 7 squared, so I rewrote it as this, right? So this I can rewrite as this, right? Remember the root is on the bottom, just like on a tree, the exponent's on the top. The 2/4 can be simplified to 1/2, and that 7 to the 1/2 is the same as the square root of 7. Right? All right, let's see what we did here. Okay, on this one, if you don't recognize what that is, just start dividing. You know, if it's an odd number, divide 3. If it ends in 5 or 0, start dividing 5s. If it's an even number, start dividing 2. So if we started doing this, you know, we'd come all the way down and we could get 2 to the 5th power times 9, right? I can't remember what, let's see, if I divide, let me see if I do that real quick off the top of my head. Yeah, 288 divided by 9 is 32. 32 is equivalent to 2 to the 5th power. Remember, 16 is 2 to the 4th power, 8 is 2 to the 3rd power. So if you know some of these basic exponential and root numbers, then you can make your life a lot easier. All right. Everybody good so far? Any questions before I move on to 12? Mr. Cohen, you okay? There's some medicine you can get for that.
No.
Okay. All right, 32. 32 is 2 times 16. We love 16 because 4 is the square root of 16. So the 16 comes out front of the radical as 4, and you have 4 square root of 2. And here's 16 again. That comes out from under the radical is 4. 4 times 3 is 12, all right? So all we did was we multiplied this 4 radical 2 times 12 to get 48 radical 2. Everybody get that? All right. This one you had to kind of think about. It's a good thinking one, all right? You can see that 5 is common to both these numbers, all right? So we rewrote these in exponential form. The cube root of 25 is the same thing as 5 squared to the 3rd root, right? Just like 125 is 5 cubed in the square root, right? So now I've got like bases. I'm multiplying so I can add the exponents, except they don't have common denominators, which the common denominator of 3 and 2 is 6, right? So I convert the 2/3 to 4/6. I convert the 3/2 to 9/6. And the 4 plus 9 is 13/6. So there's that right answer. That one you had to think about a little bit. Questions? 14 you had to think about a little bit. We know 16 is 4 squared, right? So I can rewrite this thing as the 6th root of 4 squared, all right? If I rewrite this, that's the same as 4 to the 2/6 power, which can be simplified to 4 to the 1/3, or it can be rewritten this way. Everybody good before I move on? Are you getting these answers? Neighbors don't get any speeding tickets. All right, let's see, where did we leave? Oh, we just got the one last one. All right. So I rewrote this in exponential format. All right, that's all I did was here, so I could maybe simplify. All right. Let's see, where'd I go with this thing? I'm trying to remember. Yeah. All right. So a to the first power, which is the same as 2/2, right? Over a to the 1/2 becomes a to the 1/2 in the numerator. We got b to the 4/3, which is the same as 8/6. We got 3/2, which is the same as 9/6. All right, so it leaves b to the 1/6 in the denominator. Right? So I would have taken either one of these answers. There's two different ways of writing the exact same thing. One is in exponential form, one's in radical form. All right. So you'll probably have about eight of those type problems that are on this sheet in problem set 1. Anything I can clarify or clear up before I jump back and kind of do a brief review of section 6.4 and section 6.5? Now's the time to ask. Everybody in good shape on this before I leave the page?
Yes.
You can do your own work and not screenshot it to your buddy and just let him copy it. Everybody's good? All right.
Sir, who does that?
A whole bunch of people.
Sir, but that's cheating. And at the top of every assignment, we sign an honor pledge.
Thanks, we cheat.
Sir,
Yeah.
we obviously don't cheat.
Thanks,
Yeah.
we cheat.
And if
We wouldn't sign the pledge if we did.
there'd be all kinds of the honor court would be running triple shifts if they were here.
So,
Sir, do you want to hear a joke?
Particularly when I get quizzes that have the exact same right answers and the exact same wrong answers in the exact same format.
Yeah.
Detective
Nicholas.
Detective Sir.
Sir, do you want a burrito right now?
Let's see. I'm going to go back to 6.4. All right. And do a brief review on 6.4.
Burrito!
hers is weak.
Back.
You can take some Pepto-Bismol for that, Mr. Cohen.
Sir, you need to go to Bald Head Island soon.
Okay.
So, would you hang out with me on Bald Island for free? Be honest.
Bald Head Island, Kurz and Coach.
There's
Eating
not, even
burritos.
enough, there's not enough money available.
Oh.
In the
All right.
world?
So, that's a no.
Sir, I really need a burrito.
Brilliant. Brilliant.
Sir, I
Brilliant.
gotta say, that was kind of mean.
That was me. So.
Sir, can I take you inside Taco Bell with me?
Yeah, Taco Bell, that's a good way to lose weight. Okay. All right. 1 through 6. All you gotta do is plug it into your calculator and do what it says. Make sure you pay attention to the root, all right? I just graded a couple of late ones of these, and a lot of you, there's many folks that have difficulties rounding, all right? Round to 3 decimal places, all right? So let's just say this thing came out to, I think it was 15, I think it was this. Let's talk about this. 1, 6, 5, 7. Okay. Now, some of you guys don't know how to round. All right, so we're gonna round to 3 decimal places. So that means everything to the right of that blue line goes away. If this first number that's being removed is 5 or greater, this becomes a 6. A lot of you lost 2 points. There was like four problems that this was a situation that we didn't round correctly. If this number is 0, 1, 2, 3, 4, the 5 would stay just as written. Is everybody clear on that? You're gonna lose points. You need to know how to round because you're gonna see some of that on standardized tests. All right, we're rounding to 3 decimal places, so everything to the right of that blue line is chopped off. The first number that you're chopping off, if it is 5 through 9, this number goes up by 1. If this number is 0 through 4, the 5 would stay as written. Any confusion on that? Are we good? Are we paying attention? Are we watching SpongeBob SquarePants or doing something other than Algebra 2?
Absolutely not, sir.
Yeah. Yeah. Okay, these here. Simplify. So we're bringing everything out front of the radical that we can. There's still may be stuff left under the radical. All right, if this says plus or minus, it's outside the radical, it just goes along for the ride. Don't delete it. Just let it go. That's 11, right? The square root of anything squared is itself, right? Be careful of the decimal places, right? All right, is this solvable with a negative under the radical without using imaginary complex numbers? Bueller, neighbors,
Cookie burrito.
okay? It is solvable. The answer is -2. All right? You can solve a negative under the radical as long as the root is an odd number, right? If this was 4 instead of 3, there'd be no solution because there's no two numbers I can multiply to an even power, 2, 4, 6, 8, 10, and get a negative number, right? Everybody good there? All right, let's
Yes, sir.
get this guy here. Look at each one of these things here as like terms. So the negative just goes along for the ride like that plus or minus up there, number 7. The 100 comes out as 10. P to the 4th is p squared times p squared, right? And we're doing square roots here. So p to the 4th comes out as p squared. T squared is t times t, right? So the square root of t squared is t. All right. If you didn't know this guy, since that's an odd, I'd start dividing 3 in that. And we get 3, 27. And then we get 3, 9. And we get 3, 3. And then, so the 4th root of 81 is 3. All right, anything on that side we need to talk about for 6-4? That was nth roots. This is your quiz, which you probably should have in your notebook or desk there. Everybody good there? Anything I need to talk about or clarify? Okay. We good? All right. Let me go to 6-5. Quiz, let's see. All right, let me grab my, all right. Once again, we're not going to plug this into our calculator. It doesn't say about round to 3 decimal places. We're not solving, we're simplifying. When we're simplifying, we're bringing out everything we can, all perfect squares or roots out from under the radical. So 28 is 4 times 7, right? So the 4 is, square root of 4 is 2, and we leave 7 under the radical, right? 50 is 25 times 2, right? We love 25, so it comes out from the radical as 5, and 2 stays under the radical. 32, I'm probably going to start looking at 216. All right, see if I can get 3 2s out of that. That's 2 8. I got 2 now. That's 2 4. And 2 2. All right. So here's my 3 2s, which I'm looking for to bring out. So those come out, that comes out as the cube root of 32 comes out as 2, and I still have a 4 under the radical that I can't simplify anymore. Everybody good there? 25, square root of 25 is 5. Square root of 36 is 6. The square root of r squared comes out as r, and I still got a t under the radical I can't do anything with. Can't simplify any further. Questions on those? All this ring a bell and makes sense? Is this redundant? Or are we good to go? Take a look at 5, 6, 7, 8. Anything I need to clear up there? Anything I need to clear up? Oh, let's talk about this. This one a whole bunch of people missed. All right. So 72, all right? 72 is 2 times 36, right? We love 36 because 36 is 6 squared, right? So the 36 comes out from the radical as 6, right? So 6 times 4 is 24, right? And I still have a 2 that is going to stay under the radical. X to the 4th, and either you all copied off the same person, because you all, just about 98% of you got it wrong, is x squared times x squared, right?
Correct, sir.
So the the square root of x to the 4th comes out as x squared. And we still have that 2 under the radical. A lot of you wrote x squared, but you left it underneath the radical. Everybody clear on that one? All right, anything about 6, 7, 8 I need to talk about? Yes, no, maybe so. That one's 2/3. I think everybody did well on that one. All right. Hearing no complaints, although I'm not sure how many people are paying attention. Let's see here, let's go to side 2. Let's talk about a couple of these. Here we're just kind of distributing. 3 times 5 is 15, right? The square root of 3 times the square root of 3 is like the square root of 3 squared, which is 3, right? And so that's all going to equal 45. All right. For 11 through, here we just FOIL, and then we combine like terms, right? 11 through 14 is, we're just adding and subtracting. And the one way you can add and subtract radicals is they have to have the same value under the radical to be considered like terms. All right, so we got a radical 2. I can't simplify that any further. Radical 8 is the same thing as 4 times 2, right? Well, 4 is a perfect square, so radical 8 can be simplified to 2 radical 2, right? We've used this many times. In radical 50, we've used that many times. It's 25 times 2, right? We like 25 because the 25 is going to come out from underneath the radical as 5 radical 2. Now I've got 3 like terms, all with radical 2, and I can just add them together. 1 radical 2 plus 2 radical 2 is 3 radical 2, plus 5 is 8 radical 2. Simple as that. Bada bing, bada boom. All right? Let me do one more just to make sure you know how to do these, because there is a little bit of thought has to go into these. All right. All right, 8 radical 5, I can't simplify any more than what it is. I can't simplify that 5 under the radical, all right? So I know that 5 under the radical is kind of a key component. see if I can get some 5s under the radicals of these. If I divide 5 into 45, I get 9 times 5, right? Which is a beautiful thing. So the 9 comes out under the radical as a 3, leaving 5 under the radical. Since I know that 5 under the radical is kind of my common denominator, all right, I'm going to divide 5 into 80. And what did I come up with? Let's see. 5 into 80 goes 16. So I got 16 times 5. We love 16 because I can take the square root of 16 and bring it out from beneath the radical as a 4. And now I've got 3 like terms, all ended in the radical 5. So 8 minus 3 is 5. And then 5 minus 4 is 1. So my final answer is just 1 radical 5, or just radical 5. Okay, and 12 and 14 are done the same way. All right, any questions on those? You okay, Mr. Cohn? All right, let's do this one. We got 2 minus, let's just do this. Let's scratch this out. We're squaring this, right? So it's 2 minus radical 6, right? And we're just going to FOIL, right? And then we're going to combine like terms. Give me 1 second. Get rid of that. All right. So 2 times 2 is 4. Oops, come on, pen. It's 4, right? And then I got to, let's see, 2 minus 2 radical 6, right? And then I got another minus 2 radical 6, right? That's my FO, that's my I. And then I got a negative radical 6 times negative radical 6, which is plus 6, right? I just simplified that in one fell swoop. Now my F and L are like terms and my O and I are like terms, so let's combine it all together. We get 10 minus 4 radical 6. And that's it. All right, so that's quiz 6.5. So I basically pulled about 8 to 10 questions from quiz 6.4, 8 to 10 questions from 6.5, and 10, 11, 12 questions from 6.6, since we didn't quiz on that. You don't have a quiz on 6.6, you just have the 2 problem sets. It's all there on a test. It's one sheet, 2-sided, fairly full. Make your answers clear and concise and legible. If you would, box your answers. Make sure you read the directions and do what it says. All right? Don't simplify when you'd be solving. Don't solve when you're simplifying. Read the instructions and do what it says. Because you may not know how to do it, but if you do something contrary to the instructions, then it's wrong, which is a shame because you probably know how to do it, but you're applying the wrong mechanics there. I'd appreciate if you guys would do it today or tomorrow, so I can grade them tomorrow night and I can give you, I can have them posted before class this time on Thursday, because everything ends on Thursday, right? It is a test, so it counts more than quizzes, so it's imperative that you do it. You can repair some damages or you can create some damages by doing real well or not doing so well. Let's see. Let me just do a quick roll, see how many people we lost. 6, 10, 14, 17. So we lost 5 somewhere in the process.
Nick, when did you get that haircut?
Saturday.
Hey.
Okay.
Snip, snip.
Right, I've got office hours from today, 2 to 2:30. If you run into a snag or a problem, it's all uploaded on Blackboard. Like I said, if you can do it today, that's great. Tomorrow's okay. That way I can get them graded and we can talk about it on Thursday. Thursday, we're going to wrap up some loose ends, all right? And call it a year, put a bow on it, stick a fork in it, whatever you want to call it, and wrap it. All right? If you've got any questions, issues, or problems, email me, put it back in Dropbox, all right? My class on Thursday, but the earlier the better. Watch for careless errors, and again, make sure you follow the instructions. Do what it's saying for each section. There's about 6 sections of about four problems each. Okay, 2 from each section.
Yes, sir.
2 sections from each section.
Hey, Cone.
Okay, I'll be glad to take questions.
Yo,
Cone, do you like Duke?
of course.
Oh.
Suki, we're coming to school to visit you right now.
Yeah, I'm on the way. I'm in the car.
Yeah.
Okay.
Can somebody scoop?
All right, last call for questions. Otherwise, have a good afternoon. You could, I'm giving you a 10-minute early go start the, make sure you do it.
Early dismissal.
Quiz. You can make up some damages or you can create some damages.
Yeah.
Don't screenshot
Have
it
a
and
great
send
day,
it to your,
sir.
send it to your buddy, okay?
Sir, if I get a 100, what do I get?
100?
Will you give me a hug?
No, because that's not social distancing.
No, when we get back.
Sir, have a great day. I'll see you Thursday.
No, I
Like
think
the
I'm
first
supposed to
day of
social,
next year, will you give me
I
a
think I'm
hug?
supposed to social distance from you forever.
Sir. I guess I'm going to have to retake the class then, sir.
Oh,
I'm going to fail out.
okay. All right, any other questions?
Bye-bye, sir.
All right, Mr. Veliz, you want to skip the office hours and take care of business right now?
Yes, please.
All right, so your question is,
I was gonna ask you if you can send me the problem sets for the ones that I'm missing, because I don't know why, but I don't think I can. It doesn't work when I try to download them.
you send me the numbers of the problem sets you need.
All right, I will.
I will email them to you, but I'm not going to go do your research.
Yeah, I got you.
All right, you know, we got 2 flipping days left in the quarter, and now we're scrambling for grades. All right,
I'm
you're going
sorry.
to have to do the legwork on this.
Yes,
So
sir.
which problem sets or quizzes you need, and I will send you an email PDF version of them.
All right, that's fine.
Okay.
Oh, and, another thing, I probably won't be able to get them done today just because I have a biology project due in a couple of hours. So if I don't have them done today, I'll definitely have them done by tomorrow in the afternoon.
Okay. Thursday's it. They said no ifs, ands, or buts.
All right.
Okay. All right. See ya.
See ya.
For my I have a couple missing assignments for like class and homework.
Mhm.
So, like, can I still turn those into Blackboard and get partial credit?
Send them to me as an email, don't put them in Dropbox, because it's a bear to go back through each Dropbox and say, okay, he did it. This is brand new and wasn't there, you know, when it was due 6 weeks ago. So send it to me as an email
Okay.
here by Thursday.
All right. That's it. Thank you.
Okay. All righty. We'll see you.